Hello there, Mr. Sutton here with the AB Calculus 5-7 Extra Practice Number 1 solutions on properties of definite integrals. For this set of problems, we're given these continuous functions f and h, or at least a few definite integral values for these functions. And for the first part of this problem, we want to figure out the integral from 1 to 9 of negative 2 f of x. So the key here is that we already have the integral of just 1 to 9 f of x without this negative 2. So throwing the negative 2 in there, we can really just think of this as negative 2 times this integral right here. So basically, we just have negative 2. You could think of it as being like outside the integral. You're just having negative 2 times negative 1, which just comes out to positive 2. To find this definite integral, we can split up this integral into integral from 7 to 9 of f of x plus the same limits of integration with h of x. And these each actually have values up here. The f of x one from 7 to 9 is given by this 5 right here. And integral from 7 to 9 of h of x was 4, so we're doing plus 4, which comes out to 9. To calculate this integral, I'm actually going to split this up and take out these these factors here outside the integral. So my first integral I'm going to write is 2 times integral from 7 to 9 of f of x. That's just this piece right here. Then I'm going to do minus 3 times the integral from 7 to 9 of h of x. Well, f of x integral from 7 to 9 was 5, so this is really 2 times 5. And this is going to be minus 3 times h of x was 4 there, so 3 times 4. So this is going to be 10 minus 12, which comes out to negative 2. For this definite integral, we've actually almost got this exact thing up above here. We have the integral from 1 to 9 instead of from 9 to 1. We can flip this thing upside down if we negate the whole integral. So then we're just doing negative 1, which is positive 1. On this problem, to find the value of the integral from 1 to 7, we're going to use both of these f of x integrals up here. So if I want the integral from 1 to 7, well, I already have the integral from 1 to 9, but I don't want all of that. If I take this whole integral and I just subtract the area from 7 to 9, which is what this second integral gives me, I'm just going to get the area from 1 to 7. So 1 to 9 minus 7 to 9, and then that's actually going to be, let's see, negative 1 minus 5, which is going to come out to negative 6. For this one, I want the integral from 9 to 7 of h of x minus f of x. Well, I could split this up. In fact, I'm going to do that now. So I'll have the integral from 9 to 7 of h of x minus integral from 9 to 7 of f of x. And I don't have this exact thing up here. I have both of these integrals actually with reversed limits of integration. So if I want to get the integral from 9 to 7 of h of x, I have to take the 7 to 9 integral of that and just reverse the sign on it. So this right here is actually going to be negative 4. And over here, again, I don't have the integral from 9 to 7 of f of x. I've got the reverse of that. But I can make this the integral from 9 to 7 if I just change this to a negative 5. Got to be careful, though, because we're already subtracting this integral. So flipping this upside down, I'm getting a negative 5, but I'm also subtracting negative 5, which means I'm really doing negative 4 plus 5, giving me the answer of positive 1. For this set of problems, I just have this one integral from 1 to 2 of f of x, which they tell us has a value of 5. So based off of that, our first task in part A here is to find the integral from 1 to 2 of 2f of x dx. Okay, well that's just going to be this integral literally times 2. So 2 times 5 gives us 10. For this problem, I want the integral from 1 to 2 of radical 3f of x. This is a lot like part A. If you have a constant multiplier inside an integral, you're just multiplying the regular sum of that integral by whatever that multiplier is. So this is just radical 3 times this whole integral, which is to say radical 3 times 5, or 5 radical 3. For this problem, I want the integral from 2 to 1 of f of x. That's just going to be the opposite sign as the integral from 1 to 2. So this just comes out to the negative version of this, or negative 5. For this problem, I want negative f of x integral from 1 to 2. So for this, I'm just going to take this negative outside the integral, and now I'm just doing negative whatever this integral was. Up here, the integral they said had a value of 5, so this is then just going to be negative 5.